Thank you. It's nice to be here. So, is this picture the future of winter in DC? The short answer is yes, but the details are slushy. I'm going to be a little geeky in the talk because you have this paradox about how does global warming and warming in the Arctic cause snow and cold temperatures at mid-latitudes, and no one's ever been able to address that very well, but I'll give it a shot here. It's nice when the White House has already talked through increase in temperature of the Arctic relative to mid-latitudes. I would say I'm on the 3 times end of the scale now, because mid-latitudes have slowing down of the rate of increase because of natural variability in the Pacific, where the Arctic just continued to boom on. So these are changes that have already occurred. If you asked me 15 years ago whether I'd see these in my lifetime, I wouldn't have said yes. And so looking to the future, these changes will continue. We look at least 4 degrees more changes in the fall by 2040. Basically, the fix is already in from global warming for the next 40 years. If we cut in mitigation, that'll affect the second half of the century, but we're already in an adaptation stage for the next few decades. And it's nice for a senator that already talks about the absolute uniqueness and importance of the loss of old sea ice. It's a complete shift in the Arctic system. The old sea ice was a flywheel for the climate that didn't vary much from year to year, and now with mostly first-year sea ice, that all can impact the change. And this is one of the main reasons why we think that change is locked in for the Arctic, that once you've gotten rid of the old multi-year sea ice, it's virtually impossible for us to go back to the situation that we were even a decade ago. So we have these huge changes in the Arctic where we have more open water, we absorb more sunlight rather than reflecting it back to outer space. So we're actually capturing more of the sun's energy into the planet in the Arctic. So it makes sense that this added heat in the Arctic would have a larger impact on the atmospheric circulation down more in mid-latitudes, and there's a lot of interest in the polar vortex and so on. And so people have been looking at this, particularly in the last year and a half. There have been 4 workshops on it and several review papers. And the attribution is controversial. And the issue is that we have less than a decade when the Arctic heat source is strong enough where it would really impact the Arctic. But the Arctic added heat is trying to impact a very chaotic mid-latitude weather system. And so how that bit of Arctic added heat would change a very large chaotic system is the real question. But but we take one approach to this is from a risk avoidance problem. Is there a potential that the Arctic can have a impact on mid latitudes? And the question is really important going forward because in the 1980s, the looking at El Nino was a way of looking at longer seasonal forecasts, and the continuing change in the Arctic is the next potential for improving monthly or seasonal atmospheric forecasts. I'm now going a little geeky on you for the polar vortex. If you're near the surface of the ground and you want to know about winds, you look at the difference in pressure on a level surface. The difference in pressure causes the winds. Meteorologists, when you look in the mid-latitude, kind of reverse that around, and rather than looking at pressure differences on a level surface, they start with a constant pressure surface and look at how high that is. So it's the same physics, it's just a different way of doing this. And this is looking partway up in the atmosphere of the height of these constant pressure surfaces. So in the old days, you had the pressure surface sloping down towards the North Pole, and the color bands are contours of constant height of this pressure surface. So in a rotating Earth, the wind follows these contours, and so the winds flow around in this elliptical shape, and there's a lot of angular momentum associated with maintaining that vortex. So this, in the old days, it used to be a very stable vortex. What was in the Arctic stayed in the Arctic, and so forth. Now that's the old stable picture. But then in the last 5 years, there's been 6 cases where rather than these pressure surfaces sloping down to the north, the Arctic actually has a bulge of warm air and higher heights, and that changes the wind pattern and makes the edge of the polar vortex very wavy. So here if you follow the winds, the color patterns, you have this very wavy pattern in the height field, and then these are the temperatures that go along with that. So you're bringing cold air into the U.S., and this is what we call the warm Arctic cold continent weather pattern. And under the dome of warm higher heights, you have to have warm temperatures below that, and that can either come by random dynamics or warming from below. So it's this wavier jet stream that we're seeing more in the last 5 years. How much is forced by the Arctic versus random? So for extra credit, we can look at one of these weather patterns from 2 weeks ago, and this is a false positive. To get the Arctic warming tied in with a wavier jet stream, that's mostly in the fall. By winter, things are really different. And on this one, rather than the colors being the constant heights, the contours are in white. And so you have along the East Coast, you had lower pressure over Iceland all the way up into Greenland, And so what happened for the last month is you had low pressure all the way from a nor'easter on the east coast into the Arctic. And again, the winds flow around these low pressures. So it's out of the north on the west side of these lows. So the Arctic was connected to big latitudes in that you were bringing cold air all the way from the Arctic down there due to this pattern. But there was nothing in the Arctic to help set up the wind pattern in this case. So you can't blame the Arctic change for what happened for the last month and froze the Potomac and cool things like that. And so the dark red colors are the extreme cold temperatures that go all the way from the Arctic south. So if we look at more of the December weather tied to the Arctic, there's a set of links that have to happen, which makes why the whole problem is fairly complex. That we know the Arctic change is big, but how we affect the wavier jet stream pattern is the research program. And because of the chaos, even though this occurs all the time, this will only occur part of the time. So that's one of the science problems to sort out. So in summary, the Arctic change is a one-way trip for the next 3 decades. The fix is in from what we already have. It's a small amount of carbon increase that gets amplified by all of these unique feedbacks in the Arctic. A bunch of people are working on these linkages, and there's essentially a new consensus coming between the skeptics and others that rather than prolonged cold winters that everyone's kind of afraid of, it's going to be more of a regional episodic events that will happen. And those regions are the east coast of the U.S. and the east coast of Asia. So that's the issue there. So thank you very much.